I'm recording right now. Testing. Anyway, here we are. So we're rolling. So this thing talks about epsilon and delta, and these come up in the definition of a limit. Okay. And this is not an AB topic, but it's a BC topic that needs to be addressed. All right. So what this basically says is if you have some arbitrary function, okay, so let's just draw a function like this, and we kind of talked about this. Here's C, here's L, okay, here is the point C, comma L, okay, this point right here would be C, comma L. So epsilon is the same. This is where, let me try a different color. Yes?
Can you turn off the light?
Yeah. Turn off the light. Oh, that's the light. Okay. So watch this. I'm going to make this let's take this tool and make it dotted. And let's not put arrows on the end. Okay? And let's make it a different color, like pink. Okay, so if I have to draw a line from here to here, okay, and a line the same distance, this is like really far away from L, and I go like this, and I go like this, okay? Okay? The distance, this distance from here to here is called epsilon. Okay, from L to whatever those values are. Okay, and so this f of x minus L is basically epsilon. Okay, and f of x minus c, whatever the x value is here, is basically delta. So epsilon is symmetric about this point L. So you go the same epsilon up as you go down. But do you see, because this curve goes up quickly, which side is the delta smaller on? On this side or on this side?
That's the right.
On the right side, okay? So what you're looking for is this, in these types of problems, you're looking for that little delta. Given you know the limit, given you know the function, given you know a value at which you want to find that function, and given an epsilon, they're going to want you to find this delta value right there. And what that delta value tells you is if you are within so many units of C, you are ensured that you're within epsilon units of L. That's what this says, okay? If you have some value epsilon that you want to stay this close, you want to say epsilon close to L, okay? If you want to stay epsilon units from L, what value of delta ensures that you're within that distance, okay? And that's kind of what you're trying to find in these problems. So, yes, yeah. So in my words, I wrote my own words. I try to break this down what this sentence means. If you want to ensure, if you want to ensure, I think, do you spell it insure like that? Or E-N? 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 Right, Katie's the writer, right? Insure like that?
Yeah, like insuring something.
Okay, thank you. Okay, if you want to ensure, you are within that's an epsilon, units of L, of L, that's the limit. You need to be within, you need to be within delta units of C. Okay?
Delta is always shorter than epsilon.
Not necessarily, not if it's a curve going that way, okay? But delta, you always take you're gonna, if it's a linear function, it'll be the same on either side, right? If it's a straight line, it's gonna be that delta is gonna be the same on either side. But if it's a quadratic function or exponential function or something else, that delta is gonna be bigger or smaller depending on which side you're on. But the epsilon is always the same distance from L on the top and bottom, okay? And so what I did is I made up my own problem, okay, to try to give you an example of the type of problems that you're gonna see, okay? And so this I call, okay, finding a delta when from a given epsilon, from a given epsilon. I guess you don't make your E like epsilon. And this is something that is a BC topic that supposedly you need to be able to do. Okay? So I came up with a function for, so here's the example, and I worked it out and it works okay. For f of x equals 2x squared minus 3 at c equals 1, L equals, what is L equal to if c equals 1? All you have to do is plug it in. What do you get out? -1, right? L equals -1. Okay? Given epsilon equals 0.5, find delta such that, and they say for all x, such that, and then they have that definition of the limit thing. 0 less than x minus c less than delta. This symbol means implies the absolute value of f of x minus L is less than epsilon. So this looks horrible, right? It looks horrible, but you just kind of have to, it's not as bad as it looks, okay? You just do some algebra, all right? So what you do is you start working with this one, okay? So there's some function, 2x squared minus 3, right? And 2x squared minus 3, it kind of looks, it's a steep function that goes through -3 down, right? 1, 2. And at c equals 1, you're down here at -1. So here is c, okay? Here is, whoops, that should go through -1 like that. What you're trying to find is when I am 0.5 away, okay? When I am 0.5 away from -1, okay? From -1, how far away am I from 1? You understand that? Okay? When I am, so here, this function goes through the point, when I plug in 1, I get out -1. Okay? And so what they're asking me, if I want to stay within 0.5 of -1, how close do you want to get to this limit? Okay? How close do I need to be to 1 in order to ensure that I am 0.5 units away from -1? Okay? So just watch the algebra. It's really not too bad. The first thing you do is you plug in f of x minus L in here. So you go like this. F of x minus L f of x is 2x squared, okay, minus 3. And what's L? Well, negative 1. So it's minus negative 1 is less than the 0.5. Okay? So that's what this is saying. It's saying this function is always within 0.5 units of the limit. Okay? Okay? Now you simplify what's inside the absolute value thing. You get 2x squared minus 3 minus 1 makes what? Minus 2 is less than 0.5. And now I'm figuring out this is why they wanted to do those warm-up exercises at the beginning of the section. Remember? We did those? Okay? How do I solve this equation?
Greater than negative.
Yeah, 2x squared minus 2 is less than positive 0.5 and greater than negative 0.5. Remember we did that at the very beginning of the chapter, okay, of the section? And now you just use algebra to solve for x on both sides, okay? So that's how you solve an inequality with the absolute value thing. And then you add 2 to both sides. Let's change colors. Plus 2, plus 2, plus 2, okay? And I get 2x squared is less than 2.5 and greater than, what do you get? 1.5. Now what? Divide by 2, right? So I'm going to divide this by 2, divide that by 2, divide that by 2, and I get 0.75 is less than x squared, which is less than 1.25. Now what? Square root both sides, so I get x is less than the square roots of 1.25 and greater than the square root of 0.75. And I did this on my calculator, okay? And I got 1.118, 1.118, and 0.86. Okay? What the heck does that mean? Okay? That means that your x value needs to be in that range. But that's not really delta because their delta is how far away is that from C. Okay? And so if you think about the curve again up here, let's kind of make it bigger. Okay? So if you think about the curve again, it's not much bigger. Okay? But not very good. But here is one value over here, and here's the other value over here. This value is 0.86. This value over here is 1.118. This value right here is what? 1. Okay? So from here to here, it's how far? That's 0.14. 1 minus 0.86 gives you 0.14. Yes? See that? From here to here is how far? 0.118. The smaller of these two values is your delta. Okay? The smaller of those two values is delta. So this one is your delta. Okay? Yes, sir.
Can you make that like bigger on the other side?
Bigger on the other side? Where was
Just kind of draw it.
this?
Or, yeah.
Oh,
That's hard to see.
I don't know. I could try bigger on the other side. I should use my, so bigger. So here is 1, right? Here's my function. Whoops. I could use all different colors. But, and then from here to here goes this point, and then from here so here's your epsilon, right? You want to be, here's your -1 over here, all right? Here's your epsilon right here. So this side is bigger than what's over on this side, right? So from here to here is smaller. So what the question says, how close do I need to be to 1 to ensure that I'm within 0.5 units of -1? In order to ensure that I'm within 0.5 units of the limit, I need to be within 0.118 units of +1. Okay, so that's basically what that says. And so this is your delta, because if I were to take this 0.114 and plug it in on this side, see if I'm in, or 0.14 units on this side, then my epsilon is actually going to be bigger than 0.5. You see? So, but that's why you have to take the smaller one, because if I take the bigger one and go over onto this side, then epsilon, I go over onto this. So here's my point. What did I say that was? 0.14, and here's my 0.118. Right? If I went 0.14 onto this side, which is slightly bigger than 0.118, my epsilon would be bigger than this 0.5 units that it's supposed to be. Okay? So that's why you have to use the smaller of the two values. Okay? So just to show you what you're doing on your homework, let me just flip it up. You could check the odd ones, and I just want to kind of look at it real quick. Section, graphical end matter?
Appendix 3 and matter.
End matter.
Yeah, go to appendix. It's like imagine
Appendix 3. Oh, thank you. The end matter. Sounds kind of scary. It's not working. Is it working?
Locate a bunch.
Is this up? It's not showing up. No? Yes? What's going on? No.
That'd be why.
It's like I can see it really well. It's a coded message.
Where is it? Do I have to plug this in again?
Now you put the shadow on it. There you go.
Oh!
It's like
And matter. Maybe it'll work now.
I was here. Screw you.
Doesn't work.
Left
Left clicking? Open.
Set up picture. I was here. Screw you.
Chapter 2 works. I don't know. But in any case, if you look in that appendix, the first thing. Wait. We better stop recording because that's. We're gonna stop.